Alright, Prop 30 is nice and quick and simple, and so is the proof. So the proposition says straight lines parallel to the same straight line are also parallel to one another. In other words, it establishes the transitivity of parallelism, that if two lines are parallel to the same line, they're also going to be parallel to each other. So the setup, which I'll just explain and then I'll write it really quickly, is that we can assume that AB is parallel to EF. We'll assume that CD is parallel to EF, and then we want to show that AB is parallel to CD. It's just that simple. All right. So proof. We'll first assume AB is parallel to EF, and also CD is parallel to EF. So that's what we're given. And then we just want to prove that AB is parallel to CD. That's the conclusion. All right, so we say let GK fall across them. Let GK fall across all of them. So he says, for let the straight line GK fall upon them, but maybe I'll be a little bit more explicit. It's going to fall on AB, EF, and CD. I'll just write it that way since that's kind of the way that the lines are written from top to bottom. Well, what do we know then? We've got a couple of propositions that give us some information based off of these two assumptions. Since AB is parallel to EF, we have, in particular, that angle AGK is equal to angle GHF. So AGK is sort of this top angle right here, and that is equal to angle GHF. So this little angle right here. And where does that come from? Well, that comes from Prop 29, which is the one that says that if two lines are parallel to each other, then the alternate interior angles are equal. Well, then, you can probably see where this is going now. Again, since CD is parallel to EF, we get another couple of equal angles. Which ones are they? In particular, angle GHF is equal to angle GKD. And this comes from Prop 29 also. So GHF is right in here, GKD is right down here. So Prop 29 established sort of three different conditions that are met if two lines are parallel, and this is one of them, is that GHF, so this sort of interior angle here, is equal to GKD, the interior angle on the same side. Well, okay, then if AGK equals GHF and GHF equals GKD, then angle AGK equals angle GKD. And this is just a common notion because of common notion 1, and it's cited here that they are that common notion 1 is used there. I don't know. Sometimes it's cited, sometimes it's not. Here it's cited. I'm not going to cite it. Right. So what is not cited, though, is why this gives us, again, that AB is parallel to CD, but it just, again, comes from, let's see, I guess actually it's not Prop 29 this time, right? It would be the one before it, Prop 28. Is it 28 or is it 27? Let's see, 27 was one that says, it's actually not cited in my book for some reason, and I feel like that should be cited. So I'll write out the conclusion. So AB is parallel to CD. And what proposition is this by? Let's see. 27 is the one that says a straight line falling on two straight lines makes the alternate angles equal to one another. No, that's not the one that we want. I think it's 28. makes the exterior angle equal to the interior and opposite angle on the same side, or the interior angles on the same side equal to two right angles. So I think that's the one that we want. Let's see, so we're looking at AGK right here is equal to GKD right there. So yeah, exterior angle equal to the interior and opposite angle on the same side. I think that's the one. I'm on the spot now, and I can't think very well, but I'm pretty sure it's 28 that says if this is the case, then these are parallel. So, and that's what we needed to prove. Yeah, QED. Let's see. This one also doesn't have a therefore etc. on it. I feel like it should. Maybe there's a couple mistakes in this text that I have that's sort of omitting some of those things. But yeah, in any case, this proves it. Parallelism is transitive.